Hi everyone, in this video we're going to look at linear functions. We're going to identify two different methods to be able to graph linear functions. The first method we're going to look at is using a table of values. So if I have the function y equals 2x plus 1, what I can do is draw up a table of values. So I have my x values, okay, and usually I'll just select some. It can be 5, you could add more. Now what I need to do is identify the y value when x equals that. So how do I do that? Well, when x is negative 2, so I substitute it in. So y equals 2 multiplied by negative 2 plus 1. So that's going to be negative 4 plus 1, and that's going to equal negative 3. When x is negative 1, the same process. I'm going to substitute those values in for x. So negative 2 plus 1, so that's going to be negative 1. And I would continue that process until I've completed all of the values for y. I've already done that, and I'm going to go ahead and fill the table out. And it will look like this. Okay, so now what I'm going to attempt to do is actually graph this function on a Cartesian plane. So we have still our equation, or our function, y equals 2x plus 1. We've got our table of values. Now what I want to do is try and plot this function on the Cartesian plane. How do I do that? I'm going to follow the coordinates. So when x is negative 2, so I line up when x is negative 2, which is here, y is negative 3. So I'm going to go down to that point and put a dot. Negative 2, negative 3. And I'll continue that process. Negative 1, 0, 1, 1, 3, and 2, 5. Now, as you notice, all of my lines are going to form a straight line. So I'm going to attempt to draw a straight line through those. Like so. And then on the end, I will continue with arrows, because these lines will continue on. So I would suggest using a ruler with these when you are drawing them. Put the ruler over those particular points and rule your line through. If you notice one of them is not on the straight line, then you might need to have a look at it again, because you may have made an error somewhere. Now we're going to look at our second method, so the gradient intercept form. Our gradient intercept form you may have seen as y equals mx plus b with plus c, or y equals mx plus b. Okay, we've looked at the gradient, that's our m. And then our c is going to be our y intercept. And it's the same if we see it in the other form. So our gradient is m, and our b is our y intercept. And what we're going to look at doing now is graphing using that technique, or identifying an equation given those particular points, our gradient, identifying that, and then also identifying the y intercept. So with this one, I'm going to write y equals mx plus c there. Identify the equation of the line. So I suggest you pause the video here, identify the gradient, identify the y-intercept, and form your equation for this particular line. What I'm going to do is work out my gradient to begin with. And I'm going to use this triangle. So my rise there is 6, my run is 2. So m equals 6 over 2. So my gradient is 3. Okay, if I color code this, my y-intercept is there. So my y-intercept is going to be 6. So my equation is going to be y equals my gradient, 3x, my y-intercept plus 6. That's going to be my equation of that particular line. Y equals 3x plus 6. Now what we're going to try and do is graph this particular equation using that piece of information. So we know, looking at our equation, m equals -3, and the y-intercept equals -2. So to graph these, what I'm going to do is, first of all, identify my y-intercept at -2, which is there. Now, because the gradient's -3, I know it's going to be sloping this way. Okay, so I will go out 1 and up 3. And that's going to be my second point. Okay, because if you imagine the run is 1, and then we have a 4, 2, 3. Again, what I'm going to do is get my ruler and draw my line through those 2 points. Once I've done that, again, I'll form arrows on my line. And what you can also do is write the equation on the line, like so. In our last problem here, we need to identify the equation of the line. So using y equals mx plus c, pause the video again here and attempt to identify. This time it might be a little bit different. So my y is going to be v and my t is going to be x. So looking at the gradient, I'm going to go off those 2 points. So my rise is 250, my run is 4. So m equals 250 over 4. If I simplify that, that will come down to 62.5. Now on this one, the y-intercept, it cuts at the origin. So the y-intercept is really 0. But we don't need to write on our equation plus 0. So this equation is going to look like v equals 62.5 t. So that's normally my y, it's normally my x, but because this Cartesian plane, or this first quadrant plane, the y-axis is v for volume, and the x-axis is t for time.